Good morning, friends. Today we are going to do the problem solving from the fluid mechanics MCET212 lab manual. So at the beginning of each experiment, there is a pre-lab test or problem solving which is created on the experimentation done on that week. Now let us start from the experiment number 1. So it's a basic properties of the fluid, and the problem is created accordingly for that lab. So this is the problem, and the experiment 1 is on basic properties of the fluid mechanics. How to solve this problem? The first, no doubt, write the given data. In an experiment, the weight of 5.5 meter cube. So meter cube means it is a volume. So volume is given a V of a certain liquid found to be. So weight is found. Weight is equal to F is equal to mg. It is not a force, it is a weight because it is acting downwards. That's it. It is a weight. It is not ma. It is due to gravity. So that is F is equal to mg, and it is given as 20.75 kilonewton. So remove kilo. We are using the basic SI units. 20.75 into 10 to the power 3 Newton. Find the specific weight. The specific weight is asked. That is a gamma is asked, and gamma is nothing but rho g. We need a density of the fluid and the gravity, and its density is asked. Density is equal to rho. Is how much? And density is defined as the ratio of mass by volume. So volume is given, we need a mass. So from weight we can find out the mass. F is equal to mg, we can find out the mass. So mass of the liquid, mass of the fluid is F by G. So from this formula, so G goes underground, F by G. So F is 20.75 into 10 to the power 3 Newton, and divided by G is 9.81 meter per second square. Okay, so we'll get mass M is equal to, so what is force? Force is equal to mass into acceleration or gravity. The unit of mass is kilogram, and the acceleration is meter per second square. So kilogram meter per second square is called a Newton. So here you will get mass is equal to kilogram. So doing the calculation, we will get 2115.188 kilogram. So once we know the mass, we can find out the density. So density is the first basic property of the fluid, which depends on temperature only. So density of the fluid is equal to rho is equal to mass by volume. So mass is 2115.188 kilogram, and density volume is 5.5 meter cube. 5.5 meter cube. So unit of density is kilogram per meter cube. 84.579 kilogram per meter cube. So it is very important to understand the LMT dimension also. LMT. So L is -3, kilogram is my 1, and there is no second, that's why it is 0. So this is a basic dimension. It is important for theory part. So this is a density, and now we will move to the specific weight. Specific weight is equal to gamma. This is another property of the fluid. Specific weight of the fluid is called gamma, and it is written by rho z. So density into gravity. So 384.579 kilogram per meter cube into G is 9.81 meter per second square. So I'm writing the unit here because we should understand the unit and LMT dimension. Okay, so it is very important for understanding LMT dimension. So the answer will be 3772.73. So kg meter per second square is a Newton, as we studied just, and meter cube. The unit of specific weight is Newton per meter cube, and you can write the LMT dimension by replacing in Newton. So there is a kg, mass is 1 in the numerator. Meter cube and this meter cube and this meter, it get cancelled square. So there is a -2 in denominator, and there is a second -2. Second, there are 2 in the denominator, it goes up. It's not important in the problem, but for theory, it is very important for other questions to understand this. So this is the first problem. Find out the density and this. Now we'll move to the second problem. Yes, this is again the based on the properties. Determine density, specific gravity, Sg, it is denoted by Sg, and mass of a air in a room whose dimensions are shown in figure. So this is the room, and inside the room this is the temperature and pressure. So this problem also belongs to from thermodynamics, but we will consider this as a fluid mechanics, where the temperature is not important, as shown in figure. Consider the air an ideal gas, and the gas constant of the air is given as R is equal to 0.287 kilopascal, kilonewton per meter square is Pascal, into meter cube per kg Kelvin. See, this is the unit. You can write the unit in many forms. So this is called derived unit. So I can make it a basic kilonewton. So this meter square and meter cube get cancelled. So Newton meter. So this is 0.287 kilo. Newton meter is called joules. Newton meter is called 1 joules. Kilojoules per kg Kelvin. As you know all these units. So it is important for LMT dimension how to write that. Okay. So kilo is not allowed in the calculation. So you can multiply by 1000, 287 into 10 to the power 3 joules per kg Kelvin. First, I will write all the basic units. The temperature T is given 26 degrees centigrade. Better to convert into 70 Kelvin. So 26 plus 273 is equal to 299 Kelvin. The pressure is given 8 bar. So bar is also, we will write the basic SI unit, 8 into 10 to the power 5 Newton per meter square. So bar is equal to 10 to the power 5 Pascal, Newton per meter square, or Pascal. The diameter of the cylinder is given. So I need a density. So what is density? Density is volume, mass by volume. So I need mass, I need volume. So volume, I have the diameter, I have the height. So I can find the volume of the cylinder. So for that I need the area. Area into the height is called volume. So volume is equal to, volume of cylinder is equal to area into height. So area, it is a circular cross section. So area is pi by 4 d square. Sorry, capital D square or small, doesn't matter, into height is h. So I can write pi by 4 into 5.528 square into height is 10. So I will get volume V is equal to 240.008. So check the answer from your calculator. If there is a calculation mistake, please ignore it. Do the calculation yourself. So this is a volume meter square because this is a meter square and this is a meter. So it becomes meter cube. So volume of unit of volume is meter cube. Now once you know the volume, I need a mass. So density is equal to mass by volume. Now this is the year at pressure and temperature is given. So we can find out the year accumulated in this cylinder. So mass of the year we can find by the ideal gas law. PV is equal to mRT. So here temperature is given. I know the volume and pressure is also given. So I can find m is equal to PV by RT. So P is in Pascal, pressure is in 8 into 10 to the power 5 Newton per meter square into volume is 240.008 meter cube. No need to write unit, but it is for understanding purpose I am writing so that you will get your idea. So R is given as 0.287 into 10 to the power 3 joules Newton meter joules per kg Kelvin, and temperature must be Kelvin because here it is a Kelvin, so it is must be Kelvin. So you can see here the Kelvin get cancelled. Joules means Newton meter. With this Newton get cancelled. This meter square and 1 meter square, so it will get cancelled. This meter, it is this square will get cancelled. So we will get the unit is kilogram. So mass is equal to 2236.87 kilogram. Once we know mass and volume, we can find out density. Here also you can write P by rho is equal to, because volume by mass is equal to RT. It is the same. So mass will come down and you can find density from here also. So it doesn't matter, you can find because mass is also asked. So we'll find one by one. So rho is equal to mass by volume. Mass by volume. So mass is 2236.87 kilogram and volume is 240.008 meter cube. So I will get the answer. Density is equal to 9.323 kilogram per meter cube. If you forget to write the unit, you will lose the mass as per the instruction. Once you know the density, then you can find the specific weight if it is asked density. So yeah, specific gravity is asked, specific weight if it is asked, you can find out it also. Specific gravity of any fluid is defined as the ratio of density of any fluid over density of water at 1000 at atmospheric temperature. Specific gravity you can find out. The density is 9.323 divided by 1000 and it is very less, 0.0009323, and it has no unit as it is a ratio of densities. Next experiment. The water at 50 degrees centigrade, so temperature is given as 50 degrees centigrade, flows along a 1.5-inch pipe So what is this? This is the diameter of the pipe. D is equal to 1.5 inch. So as I told, we need a SI dimensions. So 1 inch is equal to 25.4. 1.5 inch. I will replace it is 25.4 millimeter. Okay, millimeter to meter, 10 to the power minus 3 meter diameter. So remember why diameter is given, because water is running through the pipe of diameter d. So means it is necessary to find out the area in a fluid flow problem. So any fluid is flowing through this pipe of diameter d. So what is our target? You need to find the cross section area. So once you know the area, we can find out the discharge Q. So discharge, if it is given, or we can, this is the parameters we need in fluid mechanics. Discharge Q, area, this is a flow area, discharge. So I can find the velocity V is equal to Q by A as a continuity equation. Q or mass flow rate, as M is equal to continuity equation rho AV. AV is nothing but discharge rho Q. So here our target is to find out velocity in fluid mechanics. When you find velocity, khalas, finish. So this is a general flow chart. From the given problem, read the problem carefully and find whatever given from their area, discharge, mass flow rate. From this quantity, try to find at last velocity. When you find the velocity, write formula, put velocity, get answer. So diameter is given, I can immediately find the area of the pipe. It is a circular cross section, pi by 4. This is called flow section flow area. Continue reading. Flow rate of 900 kg per hour. So write first 900 kilogram per hour means 900 kilogram. I don't need hour. It is a basic unit is second. So 3, I will replace hour by 3600, 60 into 60 second. See, kg per second. What is kg per second? Per second means rate. Meter cube per second, volume flow rate. Because this is a volume and second means per rate. Like kilogram is a mass, per second is a rate. Kilogram per second means mass flow rate. So this is a mass flow rate, yam. Gram per second. Calculate the volume. Now read. Calculate volume flow rate like discharge, then a Reynolds number and type of flow. Need a velocity for that. So whatever, any problem, any formula, we need velocity. So keep target. So what is asked? It is a second priority. First, from the given data, try to find out velocity. The density of water at 50 degrees. So this 50 degrees centigrade is not important. The temperature, because as I told you, density is a function of temperature and I need to take the density at 50 degrees centigrade from the table, or it is given here. So I will write the properties. Density is 988.04 kilogram per meter cube. The viscosity is given in different unit, but the meaning is same. I will show you here how. Viscosity, first I will write. This is for always. It is in mind. It is in your mind. Now next is a viscosity is given. 546 into 10 to the power minus 6. So I don't know what is that. 546.8. 546.8 into 10 to the power minus 6 Pascal second. I don't know. Always I need a basic unit. So 546.8 into 10 to the power minus 6 Pascal is Newton second. per meter square. So this is a dynamic viscosity, or I can write it as 546 R into 10 to the power minus 6. So what is Newton? Newton is kg meter per second square, second as it is, and meter square as it is. So this second get cancelled, meter square get cancelled, you will get 546.8 into 10 to the power minus 6 kg meter. This get cancelled, this second get cancelled, in denominator kg meter second. So this is one of the unit of viscosity. Now this is a kilogram, or Newton means it is a dynamic viscosity. It is a dynamic viscosity, mu. Okay, so sometimes mu is given or kinematic viscosity nu is given. So accordingly we need to use the formula. So here you can see in the problem twice or this value will be given, this will be not given, this will be not given, this is given 0.5534 into 10 to the power minus 6. So I will write that, and that is a kinematic viscosity. Kinematic viscosity is given 0.55347 into 10 to the power minus 6 meter square per second. Meter per second means kinematic viscosity is given. So both I can convert in dynamic viscosity also. So mu is equal to, the relation between dynamic viscosity and kinematic viscosity is mu by rho is equal to, the mu is 546.8 into 10 to the power minus 6 kg meter per second. This is the best unit to write LMT also instead of Newton second per meter square. And rho is 988.04 kilogram per meter cube. See here, you will get same answer, 0.55347 into 10 to the power minus 6 meter square per second. So anyone is given to you, you can find out it. Now come to the problem. So as I know, we need to find discharge. So for discharge we need velocity. So mass flow rate is given, so I can write the continuity equation. M is equal to rho AV is equal to rho Q. Okay, so this will give me the discharge. So discharge is equal to mass by rho, simplicity. So mass is given to you 0.25 and density is 988.04. So you will get 2.259 into 10 to the power minus 4 meter cube per second. This is a discharge. Okay, or we can find out the velocity from here directly. So velocity is equal to m by rho a. Lot of methods there. Okay, this is the basic formula I told you. So where which will give you AV is equal to Q. So V is equal to Q by A, or Q by A, or Q by A. So what is discharge? You can use this, or mass flow rate, it is same to you. So 2.259 into 10 to the power minus 4 meter cube per second divided by area. Area is 1.14 into 10 to the power minus 3 meter square. So we'll get velocity meter cube, and this square get cancelled, meter per second, and answer velocity is 0.2219 meter per second. Once we know the velocity, we can find out Reynolds number. Re is equal to rho Vd by mu. If mu is given, or take this rho down, mu by rho is nu. So Vd, take this rho down. Mu by rho is nu kinematic viscosity. So what is given to you? If dynamic viscosity is given or kinematic viscosity is given, you can use the formula. So everything is known. Reynolds number is equal to 988.04 into velocity is 0.2219 into diameter is 0.0381 divided by kinematic or dynamic. So I will write rho here. So dynamic viscosity I will write 546.8 into 10 to the power minus 6. So Reynolds number which has no unit, if you put the unit, all unit will get cancelled, and it is a number which has no unit. So 15,275.245. Yes, it has no unit. So Reynolds number, it is asked to find out type of flow. It is asked to find out type of flow. If Reynolds number is less than 2100, it is called a laminar flow. Laminar flow. If the Reynolds number lies in between, if Reynolds number is greater than 2100 and is less than 4000, then it is called transient flow. Transient flow. And if Reynolds number is more than 4000, if Reynolds number is greater than 4000, then it is called turbulent flow. Turbulent flow. So the type of flow is a turbulent flow. More than. So convert the following unit. This is very simple. 1 bar, as I told you, 1 bar is equal to 10 to the power 5 Newton per meter square. 1 kilonewton meter square. Simply replace kilo. Kilo means 10 to the power 3 Newton per meter square. Mega. Mega means 10 to the power 6. And kilo. So 6, 10 to the power 3. 3 and 3, 6. 1 megapascal is 10 to the power 6 Newton per meter square. Pascal. So this is a very basic simple unit. So next experiment is the pressure measurement. So the experiment is on this. So there are 3-4 instruments which are used for the pressure measurement. So first, the basic instrument used is a barometer, which is used to measure the atmospheric pressure. It is like a tube. Depends on the density and mass, the fluid will be rise, and that rise is the pressure head. So pressure is the next problem. The oil flow rate in the pipe is determined by Venturi. So before solving this problem, I will go little theoretical. So this question is very important, the flow measurement. So how the flow measurement is done? Or this question asked in interviews, which are the flow measuring devices, or the flow is measured by using following devices. Venturi meter. What is Venturi meter? I will not go in detail. It is a convergent divergent nozzle, CD nozzle. CD nozzle, convergent divergent nozzle, having convergent and divergent angle is same, or convergent length and divergent length is same. So this is area is increasing, area is decreasing. Like this is called a convergent divergent nozzle if the flow is flowing like that. So here the pressure energy is converted into kinetic energy, pressure energy. So high pressure energy drops and velocity increase, kinetic energy increase. And here this is a divergent part. It is the pressure is increased little bit to avoid the vibration or black flow. The minimum area is called a throat. The minimum area is called a throat. So this is the inlet area and this is the outlet area and this is a throat area. Okay, so this is inlet as denoted by 1, outlet as denoted by 2. Pressure drop is measured at the inlet at 1 and throat 2. Okay, so this is called throat by using a U-tube manometer. So you can measure this pressure, difference pressure, and then you can find out the flow measurement Q, discharge. So discharge measurement is nothing but the mass measurement. It is nothing but rho AV is equal to rho Q, and anyhow we are measuring velocity V in terms of H. So in terms of H, so what is the relation between pressure head and velocity? And velocity is V is equal to under root 2 GH, or H pressure head is equal to V square by 2G, that you used in Bernoulli's equation. So this is a kinetic energy. So Venturi meter is a convergent divergent nozzle where convergent and divergent length is same. This is an important point. Number second two, the device used is a orifice. Orifice. It is a circular disc having a hole. It is a disc. If you see in the side view, it is a having hole here. This is inserted in a pipe. Third is a pitot tube. Pitot tube. So these are the three devices. The device is same, equation is same. So there is a equation by deriving Q is equal to A1 V1 is equal to A2 V2. Mass neither be created nor be destroyed. Law of conservation of mass. Continuity equation. Rho A V1 is equal to rho A V2. So this is law of conservation of mass. This equation is derived. Then velocity V1 is found out in terms of formula H. So there is a experimental method. We can collect the 10-liter water. We can measure the time. So that is volume by time is called a actual discharge. Volume by time. And if you apply the Bernoulli's equation across 1 and 2, potential energy is converted into kinetic energy. They apply the Bernoulli's equation and then we will get a theoretical discharge. And that theoretical discharge is given by the area at inlet, area at outlet, under root 2G height of a manometric height divided by A1 square minus A2 square. Same formula, it will be written as A1 A2 under root 2G. H is nothing but, so this is a gamma specific weight is equal to height. By applying Bernoulli's equation, you will get this equation. So this is, if I put it here, P1 minus P2 divided by gamma. Gamma means rho G divided by kull A1 square minus A2 square. So this G get cancelled. So I can write directly equation. Q theoretical is equal to A1 A2 under root 2 P1 minus P2 divided by gamma divided by rho, because G get cancelled, divided by rho into A1 square minus A2 square. This is one of the formula. If the pressure difference is given, P1 minus P2 is given. If P1 minus P2 is given in Pascal, we can use this formula. If it is given pressure head, we can use this formula. Okay. Now, the formula remains same if you use orifice or Venturi. Theoretical is equal to A1 A2 under root 2GH of water, or what is flowing, A1 square minus A2 square. Sum of the book, the formula is written as Q theoretical is equal to, the outlet area is taken, under root 2G. Okay, so take A1 common. So this is 1 minus A2 square by A1 square. Okay, and here you will get EA1, so that EA1 is get cancelled, and this formula is written, and this is replaced by M. This is replaced, so the formula is written like this: A2 under root 2GH 1 minus M square. I can write this also: A1 under root 2GH divided by M square minus 1. So whatever you took, this is a mathematical operation. So no need to introduce this M. No need to introduce M. Here M is equal to, what is M here? A2 by A1. A2 by A1. And here what is M? M is equal to A1 by A2. So why to confuse the same? No need, both are same. So this is the basic formula. No need to change. Okay, so come to back. There are only two formulas. I will delete this also. See, one formula is this: if the pressure given in H, if P1 and P2 is given, I can write Q area minus smaller area. Remember, if you do reverse, if you get minus, it will not be solved because under root of minus is not possible. Problem, the oil flow rate. Oil means first I need a density of oil, rho of oil. It is given as specific gravity of oil is given, specific gravity or relative density RD is given as zero point 0.6 relative density. So it is same, both are meaning same. So density will be 600 kilogram per meter cube. Okay. Then by Venturi meter using the information given. So what is given? So D1 is equal to 21 centimeter immediately, 0.2 meter, convert to meter. D2 is equal to 10 centimeter immediately, 0.010 meter divided by 100. Calculate area A1, pi by 4 D1 square is equal to pi by 4 into 0.2 square. So you will get A1 is equal to A1 of mercury is given, H of Hg is given 5 centimeter. So is equal to 0.05 meter. So what is flowing? Oil is flowing. So I need H of oil. So there is a formula, or you can convert mercury into oil or whatever flowing, and what is the manometric fluid we can convert by using this. So what is flowing through the pipe? Oil is flowing. So height of oil is equal to the density of mercury, what is in manometer, divided by density of what is flowing minus 1 into height of mercury. So this, there is a derivation for this formula, but we are not going to use the derivation now here. So I can find H of oil is equal to, the density of mercury is not given, it is 13,600. If not given, assume it. Density of oil is given 600 minus 1. The height of mercury is 0.05. 1.083 meters of oil, because we are interested in oil, not in mercury. Mercury is a tool to measure the H only. Okay, so this is H of oil is known to you. Now H is known. I will use this formula. Area is known. I can find out theoretical discharge. Theoretical is equal to A1 A2 under root 2GH of oil, because oil is flowing, divided by A1 square minus A2 square. Okay, so there is a coefficient of discharge, it is D. So if you measure 10 liter water, if you measure 10 liter water and if you measure the time, so you will get actual discharge. And by measuring the pressure, you will get theoretical discharge. So the question arises, which is more, actual or theoretical? The theoretical will be more because there is no losses. It is assumed theoretically, frictionless. Actual, there is a friction loss, there is a measurement loss, time loss. Actual discharge is less and theoretical discharge is more. So the formula is actual by more. So this is a small and this is big. So your value will be around 0.92 to 0.98 for Venturi and 0.6 to 0.7 for orifice, remember. You can write directly actual discharge is equal to Q actual is equal to CD Q theoretical. Put the values now. CD is given as 0.98 into area 0.0314 into 0. Whole square, keep the bracket here, and it is under root everything. So student make a mistake here in this calculation, they forget bracket or something happens here and they will get the wrong answer. So here you will get actual discharge is 0.0366 meter cube per second. Calculate the flow rate assuming uniform flow and no losses. Then flow rate. This is a volume flow rate. But if teacher want a mass flow rate, so this is the actual volume flow rate or discharge, and mass of actual mass flow rate is equal to rho q. Actual, if I use actual, so density of oil is 100 and 0.0366. So this is kilogram per meter cube and this is meter cube per second. So mass flow rate I will get it 21.97 kilogram per second. Now we'll move to the orifice. The same as explained in the diagram. The orifice it acts as a venturi again. It is shown by the hidden line C. So why we change the formula? The formula should be same like what we used in Venturi. So same formula we can use here in the book. In some of the book I told you actual is equal to CD Q theoretical and Q theoretical CD is equal to, in some of the book it is used AO. AO means this area of orifice. This area we are assuming A2 and this is A1. So here it is written outlet area, that is A2, last problem I told, under root 2GH, what is flowing, 1 minus, because here A1 and A1 get cancelled, 1 minus M square. My question, why M? Why M? Delete it. What is M? Is it mass flow rate or constant? As I explained. So as usual, I told you Q theoretical is equal to, try to get all the data. Read the problem. Write the data. A orifice meter with a diameter means orifice diameter means A2. D2 is given. D2 is equal to 15 centimeter. Immediately 0.15 meter. Pipe diameter is D1. So always D1 is bigger than D2. So smaller is D2, bigger is D1. 30 centimeter. So 0.3 meter. So calculate the area. A2 is equal to and A1 is equal to. So A2 is equal to pi by 4 D2 square, pi by 4 into 0.15 square is equal to 0.01767 meter square. Similarly, I can find A1 is equal to pi by 4 into 0.3 square is equal to 0.070685 meter square immediately. Now, next, the pressure difference is measured by HG oil manometers. So here mercury manometer and oil is flowing here, and there is a mercury manometer here. So I need to convert that mercury. So H of mercury is given as 50 centimeters, so is equal to 0.5 meter. So I need to calculate H of oil, again same. Density of mercury minus the oil minus 1 height of mercury is equal to density of mercury is 13,600, so 900 minus 1 into 0.5. The answer is 7.05. Now find out Q actual. So Q actual, not theoretical. We'll get answer 0.13742 meter cube per second. Sometimes it is asked as LPM. So I can change it 137.42 into 10 to the power minus 3 meter cube per second. 10 to the power minus 3 meter cube is nothing but liter divided by second as it is. Okay, if I want minute, 137.42 liter. Second means by 60 minute. So means I will get 137.4. 1 by 60 means 60 liter per minute. Means it is 8245.2 liter per minute, means LPM, liter per minute. Okay, so you can calculate Q actual, then M actual. M actual is equal to rho Q actual. So rho is 900. Same problem, 0.13742, and it is 123.678 kilogram per second. This next experiment, friction losses. Friction losses means HF, head loss due to friction. So calculate the friction factor. Friction factor is denoted by F. Is a friction factor. Friction factor. Okay, it is asked to find out. It is asked to find out Reynolds number. Reynolds number. Discharge. Calculate the friction factor, discharge, Reynolds number when the pipe diameter and length is. So write the given data. Diameter is 21 meter. So millimeter 0.021 meter. The length of the pipe is given L 90 centimeter. 90 centimeter means divided by 100.9 meter. Okay, length and diameter. The volume of water. Volume of water is given 15 liter. So 15 liter, I told you, liter is not SI unit, 10 to the power minus 3 meter cube. The volume of water 15 liter and time to collect amount is, so time required to collect is 84 seconds. So this 15 liter water, we need 84 seconds. So we can find out discharge. The head loss due to friction, it is denoted by HF, head loss due to friction. Head loss due to friction. Head loss due to friction, and it is given as height 2.2026 millimeter of Hg. Millimeter is not allowed, so convert it in meter. So HF is equal to 2.206 into 10 to the power minus 3 meter of Hg. Then take density of water is equal to 1000. Yeah, as usual, we are going to take that only. Then mu is equal to 797 into 10 to the power minus 6 kg meter or Newton second per meter square. As I told, both are same, kg meter second. As I told you many times, what is fluid mechanics? Fluid mechanics is applying continuity equation rho a v. My target is to find velocity. Anyhow, how I can find? Okay, so to find velocity, we need a diameter, find out area, then discharge, and then discharge by area will get velocity. This is the flow chart. Khalas, finish. So whenever you get velocity, put the formula, put values, and get answer. So here think about what is given. Either mass is given or discharge is given. How I can calculate mass or discharge? So here it is very easy to see discharge Q. So Q is volume by time. So Q is equal to volume by time, meter cube per second. So volume is 15 liter, 10 to the power minus 3 meter cube. Time is 84 seconds. So I will get discharge is equal to 1.786 into 10 to the power minus 4 meter cube per second. Once you know discharge, find out area and find out velocity. So flow area is equal to A is equal to pi by 4 t square. Know discharge and velocity, I can use this. Velocity is equal to rho q. So q a v is equal to q, v is equal to q by a. So velocity, flow velocity is equal to q by a. Once you know velocity, I can write formula, put value, get answer. So write the formula. First formula for Reynolds number, R-A-Y-N-O-L-D. Reynolds number is equal to rho VD by mu. Mu is given, or VD by nu. So this is correct. I will use this because mu is given. So rho turbulent flow. This may be added in question. What is the type of flow? Turbulent flow. Okay. Now a friction factor I need to find. Head loss due to friction is given by there are lot of correlations available. Okay, so these correlations are developed by the scientists, and the equation is as per their name. So there are many scientists who worked on the head loss due to friction, because the pipe is not smooth, pipe is rough. If the pipe is rough, then there is a pressure drop, and this pressure drop is given by Darcy, Fanning, Blasius. Loss due to friction is given by Darcy. Chuff head loss due to friction is equal to F L V square by 2GT. F is the friction factor, so I can find friction factor is equal to HF into 2GD divided by LV square. I need HF is equal to HW is equal to rho of Hg, what is mercury nanometer, rho of water minus 1 H of Hg. So as water is flowing and mercury manometer is used. So 0.0278 meters of water. So I can put this value in the friction factor. Darcy F is equal to HW HF is equal to 0.0278 into 2 into 9.81 into diameter. Correct way of writing, don't write 4.8 into 10 to the power minus 2. This is the wrong way of representing. So friction factor always lies from 0.00 something. So this is by Darcy, so I can write here Darcy, I can write FD. Similarly, I can find by Fanning and Blossius also, but it is not required. We can see this detail in the experimentation. So here we are using by only Darcy. Fanning and Blossius, this equation should be given to you so that you can use that equation and find out this. A water flow rate liter per second. So this is a discharge liter means volume flow rate. Q is equal to 20 liter per second is equal to 20 into 10 to the power minus 3 meter cube per second. D is equal to given 3 centimeter is equal to 0.03 meter. The pressure drop across the wall is measured as 2 kPa. So here it is a inlet and here it is a outlet. So P1 minus P2 is given 2 kPa. So delta P is equal to 2 kPa is equal to 2 into 10 to the power 3 Pascal Newton per meter square. Determine the irreversible head loss HF. Now the water is flowing, means we need to use the properties of water. So whatever needed, the density, no need to write, we know, we already wrote in the mind. Apply the Bernoulli's equation. Bernoulli's equation. So what is Bernoulli's equation? The energy at inlet is equal to energy at outlet. So what are the energies at inlet? So first energy at inlet is a kinetic energy, pressure energy, potential energy. So energy at inlet is equal to energy at outlet. So energy is constant. So pressure energy, what is pressure energy? P1 by gamma plus kinetic energy, velocity V1 square by 2g plus potential energy Z1 is equal to the energy at outlet, pressure energy gamma plus kinetic energy V2 square by 2g plus potential head H2 plus head loss due to friction. This height at inlet Z1 and Z2 is same. So Z1 and Z2 height of inlet from datum or from the horizontal. It is a horizontal. Z1 and Z2 is 0. Select the same terms P1 minus P2 over gamma, then plus V1 square minus V2 square by 2g is equal to HF. The pipe diameter remains same. So D1 is equal to D2. There is no change in diameter. So velocity will not change. V1 is equal to V2. So as A1, A2 same, velocity V1, V2 same by law of conservation of mass. A1, V1 is equal to A2, V2. If area is same, velocity is same. Now here V1 and V2 is same, so I can change this, cancelled. So we can write HF is equal to P1 minus P2 by gamma 0.2038 meters of water. So this is the head loss due to friction. Sometimes in the question it is asked find K factor. The head loss due to the friction is given by HF is equal to HW is equal to K factor into V square by 2G. Okay, so here I can find K factor of the wall is HF into 2G by V square. So K is equal to HF is 0.2038. Velocity is, did I find velocity? No. So I can find out velocity here. Now determine the irreversible head loss. So by Bernoulli's equation, I find the head loss. Okay. Sometimes it is asked also find out Reynolds number, find out velocity. So I can find the velocity by finding the area. So area is equal to A is equal to pi by 4 d square is velocity is equal to V is equal to Q by A Q 28.29 meter per second. So if it is asked find out K factor for the wall. So K factor for the wall is head loss due to friction is equal to K V square by 2G. So this can give me K is equal to HF 2G by V square is equal to HF is 0.2038 into 2 into 9.81 divided by V is 2829 square. So K factor for 0.004991. This is a K factor. Now next, let's calculate the flow Q. The Q is asked through this pipe. The velocity V is asked. Consider H. Where is H? Is nothing but the height level of the water, 25 meter. This is called a head loss. So HF is given, HF or height is given 25 meter. So this is high means water will flow from like this. So head loss due to friction. There is a friction in the pipe. There is a head loss in elbow. So all the losses are given here. Why I am writing here? From this K entrance, there is a head loss here. At the entrance, there is a pressure drop. Then there is a pressure drop at gate wall. So this is a gate wall. Then elbow, one, two elbows are there. 45 elbow, where is 45 elbow? So this elbow, 45 elbow is not there. K exit. So head loss at exit. And there is a friction factor, head loss due to the friction. We have to consider all the losses 1, 2, 3, 4, 5. Only expecting one. So calculate. So how to solve this now? The total head loss is nothing but head losses at number 1. Head loss at entrance is equal to H1 is equal to V1 square by 2G. The velocity remains same as the diameter is same 20. Okay, so V1, V2, V3 same. Then number 2, head loss at elbow, 90 elbow is equal to H2 is equal to, so there are two elbow, I can write twice. H1 is equal to H3 is equal to V square by K entrance, K elbow, K entrance by 2G. Okay, so this is one of head loss. Now gate wall, head loss gate wall again is H4 is equal to K gate into V square by 2G. Number 4, head loss at exit. Head loss at exit is equal to H5 is equal to K exit V square by 2G. Number 5, head loss due to friction by Darcy. HF1 is equal to FL V square by 2GD. Okay, so this all addition of total head loss H is equal to HF is equal to H1 plus H2 plus H3 plus H4 plus H5 plus HF1. Okay, so this is total is given. So I can write at 25. I will put the values now. 25 equal to H1 at entrance A entrance V square by 2G plus H2 H3 same. So I can write twice A elbow elbow into V square by 2G. I will write twice. Two elbows are there plus gate wall into V square by 2G plus K exit into V square by 2G plus Darcy FL V square by 2GD. So I can take the V square because I don't know V. So I can take the V square common. So 25 is equal to V square by 2G into bracket K exit entrance plus 2K elbow plus K gate wall plus K exit plus FL by D. So put the values 20 length. Now L is very important here. The L is equal to, this is 2 meter, 5 meter, and this length is again 2 meter because it is missing here. So it is a 2 meter, 2 meter plus 2 meter plus 5 meters. So L is equal to total length of the pipe. So total length of the pipe is 5 plus 2 plus 2 is equal to 9 meter. So I can write here that 9 divided by diameter of pipe is 0.02. Here it is given 20 millimeter. So solve this equation and we'll get velocity is equal to V is equal to, solve this equation by solver, or we can solve it. 25 is equal to V square divided by 2 into 9.81 into 13. So this will be total is 13. So V square is equal to 25 into 2 into 9.81 divided by 13. So V square is equal to 37.73. So this will give V is equal to 6.14 meter per second. Now Q is equal to AV is area of 5 pi by 4 into 0.02 square into velocity is 6.14 is equal to 0.0964 meter cube per second. So a water discharged from the reservoir as shown in figure, the atmospheric into the atmosphere through the pipe of 50 milli long. So total is 50. So L is equal to 50 meter long. The sharp edge, there is a friction loss at K1. So this is K1 is equal to 0.5 at point 1. Sharp entrance due to the pipe diameter is D1 is equal to 105 millimeter is equal to 0.105 meter, and L1 is 20. D1 L1 is 20 meter from this. So this is a 105. The diameter D1 is 105 and L1 is 20. So remaining will be L2 is 30 as 50 minus 20. So D2 is 70 milli, 0.07 meter, and L2 is equal to 30 meter. So friction factor is given, F1 is equal to 0.004 and F2 is 0.002. So this is pipe number 1 and pipe number 2. So the data is written there. Then the discharge is given, Q is equal to 35 liter per second is equal to Q is equal to 35 into 10 to the power minus 3 meter cube per second. Take the Darcy friction factor, done. So it is asked to calculate H. There is a head loss at entrance due to the sharp edge. Then there is a head loss due to friction by Darcy, number 2. Then there is a head loss, number 3, due to sudden contraction. Then number 4, there is a head loss due to Darcy. Then there is a head loss at exit. So we need to consider the 5 losses. Number 1. So for head loss, we need to find velocity. So we need to find V1 and V2. So first we will find the area. So area A1 is equal to pi by 4 D1 square. Similarly, I can find A2 is equal to, as I know area, I can find out velocity, V1 and V2. V is equal to A1, V1 is equal to A2, V2. So this will give me V1 is equal to Q by A1 is equal to 4.07 meter per second. Then similarly I will get V2. A2 is equal to Q by A2 is equal to 9.09 meter per second. So as I know V1 and V2, head loss at entrance is equal to H1 is equal to K1 V1 square by 2G is equal to K1 is 0.5 into V1 square. V1 is 4.07 square by 2 into 9.81. So it's equal to dash meter of water. So head loss at entrance. Then number 2, head loss due to friction is equal to HF2 is equal to F1 L1 V1 square by 2G T1. So F1 is 0.004 into 20 into V1. V1 is 4.07 square divided by 2 into 9.81 into diameter. D1 is 0.105 dash meter. Number 3, head loss due to sudden contraction. SC is equal to HSC is equal to KSC into V square by 2G. So here it is very important to take 2 or 1. 2 or 1. I will see here now. Sudden contraction. So this is a flow direction here and this is a sudden contraction. So I need to use this formula. KL is taken from graph. So I need to consider outlet velocity. Very important, outlet velocity, because there is a vena contra. There is a vena contra here, and we have to measure the outlet velocity. The minimum area depends on the inlet pressure. So this K is taken from the graph. So graph D2 square and D1 square. So I need to find D2 and D1 square. Here it is a V2 square outlet square K, where KC is taken from graph at D2 square by D1 square is equal to. So here we will get a D2 square by D1 square is equal to 0.44. 0.444. Okay, so go to the graph and find out. From graph we will get ASC is equal to. So go to the graph from center. Yes. So from this is a center point. This is for phi. Okay, and now half of that is 0.44 is here. So go up vertically, exact vertically. Yes, it will cut the curve here. From this, go horizontally. Yes, little up. Yes, this will be 0.3. So you can take 0.26, 26 or 27, doesn't matter. So we'll take K is equal, AC is equal to 0.26. So we can find out the head loss due to sudden contraction HSC. ASC is 0.26 into V2 square is 9.09 square divided by 2 into 9.81 is equal to 1.094 meters of water. Number 4, head loss due to friction F2 by Darcy is equal to HF2. HF2 is equal to F2 L2 V2 square by 2GD2. So put the values. Fifth, head loss at exit equal to K exit into velocity V2 square by 2G. K exit is assume 1. So here the K exit is assume 1. Why? I will explain here. So this is a pipe and this is a exit. So water is flowing outside. So if you see the exit area, if you see the exit diameter is D2 and this is inlet diameter is D1. So D2 is around infinity. So A2 is infinity. Okay, and this as a sudden expansion, and as we know for sudden expansion, see here as for sudden expansion here d1 square by d2 square infinity square means it is this term is a meaningless. So what is remaining? 1. So this is the reason why we are taking at exit factor is 1. Total head loss is equal to H is equal to the addition of all H1, that is entrance, plus friction factor F1, plus there is a sudden contraction, plus there is a friction factor for pipe 2, plus exit H5. And if you enter the values, 9.6805 meters of water. So this is total head. Now second problem. It's the same problem, similar problem. The pipe is changed now. Smaller pipe is at the beginning. So we'll collect the data. We will write the data from there. The water discharge from reservoir as shown in paper into the atmosphere. So L is again 50. So L1 is equal to 20 meter, where the diameter D1 is equal to 70 millimeter, is equal to 0.07 meter. L2 is equal to remaining length 30 meter. D2 is equal to 105 millimeter, is equal to 0.105 meter. Consider the all losses at entry, exit, friction factor, both everything. Calculate the difference of the level, calculate H. So this H is asked is equal to how much. The discharge is given same is equal to 35 liter per second. So liter is not allowed. 35 into 10 to the power minus 3 liter cube divided per second. Take Darcy friction factor. So F1 is equal to 0.002 and F2 is equal to 0.004. Now we'll find first the velocity at pipe 1 and 2. As you know the discharge. So by continuity equation, Q is equal to A1 V1 is equal to A2 V2. So means to find out velocity, I need area. So before that, I will find the area A1. A1 is equal to pi by 4 into D1 square. 0.84 into 10 to the power minus 3 meter square. And A2 is equal to pi by 0.6 into 10 to the power minus 3 meter square. As we know area A1, A2, we can find out V1 is equal to Q by A1. 9.09 meter per second. Similarly, we'll find V2. So V2 is equal to Q by A2 is equal to 0.07 meter per second. So as you know velocities, we can find out the one by one head loss. So first head loss is at entrance, number 1. Then number 2, due to the friction factor F1. Number 3, due to sudden enlargement. Number 3, sudden enlargement. Again due to the friction by Darcy. And then exit. So this is 4, 4 and this is 5. Exit 5. Number 1, head loss at entrance is equal to H entrance is equal to H1 is equal to K entrance into V1 square by 2G is equal to 0.106 meter of water. Number 2, the head loss due to friction F1 by Darcy is equal to HF1 for first pipe is equal to F1 L1 V1 square divided by 2G D1 is equal to 0.4065 meter. Number 3, head loss due to sudden expansion or enlargement is equal to HSE is equal to KSE into V square by 2G. Which V? I need to see for enlargement, inlet or outlet. So go to the first diagram. Yes, here. See, this is a sudden enlargement. So I need to take this V1 square and I need to use this formula. Inlet velocity is important here, V1 square, where KSC is equal to 1 minus D1 square by D2 square whole square. 0.3086. So we'll put this value above and we'll calculate HSC. 1.2998 meters. Number 4, head loss due to friction F2 is equal to HF2 is equal to F2L2 V2 square divided by 2GT2. So put the values. 0.844286 meter. So this is HF2. Now the last, fifth, head loss at exit is equal to K5 is equal to K exit into V2 square by 2G is equal to K exit is assume 1, and I told you reason why it is assume 1. 0.844286 meter. Total head loss is equal to H is equal to H1 plus HF1 plus HSE plus HF2 plus H5 exit. Is equal to 7.215 meter. Next problem. Last experiment, which is on performance of the pump, and the problem is created on the pump performance. So let us read and write the given data. In a test of centrifugal pump, the following data is given. So this is point number 1 inlet and point number 2 outlet. P1 is equal to 13332 Pascal, means Newton per meter square. Minus is taken for vacuum. Remember, this is very important. The P2 is given as 66661 Newton per meter square. The pipe diameter at inlet, this is a D1 and this is D2. So D1 is given as 12 centimeter and D2 is given as 5 centimeter. Discharge is given as 180 GPM, gallon per minute. It is given US gallon. So I need to write in meter cube per second SI unit. It is equal to 180 into 3.785. This is a US gallon. 1 US gallon is equal to 3.785 liter. And minute is as is it. So is equal to 180 into 3.785 liter means 10 to the power minus 3 meter cube. And now minute is nothing but 60 seconds. So here Q is equal to, I will get 0.011355 meter cube per second. Calculate the pump head. It is asked. Calculate the HP head of the pump and power develop, power output. It is a power output. How much? Power I, input power. If efficiency of the pump efficiency is given 0.75. Density of water is given as it is a known, I know already. So density of water is 1000 meter kg per meter cube. So I can get a specific weight of water is equal to 1000 into 9.81 is equal to 9810 Newton per meter cube. Apply the Bernoulli's equation at in and out. At point 1 and 2, apply the Bernoulli's equation. So what is Bernoulli's equation? The energy at inlet is equal to energy at outlet. What are the energy available at the inlet? The energy available at inlet is a pressure energy, kinetic energy, then a potential energy due to the height, potential energy, and some energy from the outsource or from the machine. Okay, so this is the energy at inlet is equal to energy at outlet. Some energy is added in the water by the pump and same energy at outlet, potential energy, kinetic energy. Applying Bernoulli's equation, the pressure energy P1 by gamma plus kinetic energy V1 square by 2G plus potential head H1 plus P, the head developed by the pump due to impeller rotation, is equal to the pressure energy at outlet plus kinetic energy at outlet plus Z2. Now, here what we need, the pressure P1 and P2 is given to you. Now, velocity V1 and V2 I need to find. As discharge is given, diameter is given, I can find out velocity. Then I can find HP. So discharge is equal to Q is equal to A1 V1 is equal to A2 V2 by continuity equation. So for that I need a area. So I can find area A1 is equal to pi by 4 D1 square is equal to 0.01131 meter square. Similarly, A2 is equal to pi 0.9635 into 10 to the power minus 3 meter square. As we know area, I can find out velocity. So velocity V1 is equal to Q by A1 and V2 is equal to Q by A2. So put the velocity V1 is equal to 1.004 meter per second. Similarly, I can find out 5.780 meter per second. So as you know, velocity V1, V2, P1, putting all values in equation, Bernoulli's equation number 1. So minus 1332 divided by 9. So here the oil is flowing through the pipe. So this is a oil. It is a confusing. The water density is given, so we think it is a water is flowing. So here is a chance of mistake. So it is unnecessarily given, and we know that the oil is flowing through this. See, I was going to make a mistake, but I remember the oil is flowing to here, so I need to find. So density of mercury is given here, so this no need. So density of water is given as 1000 kg per meter cube. So this will give me density of oil, that is specific gravity into specific gravity 0.91 into 1000, 910 kilogram per meter cube. Gram per meter cube. Specific weight of oil is rho g is equal to rho is 910 into 9.81 is equal to 8927.1 Newton per meter cube. So this is the specific weight. Now come to the Bernoulli's equation. So here pressure is given, gamma is 8927.1 plus velocity v1 square 1.004 square divided by 2 into 9.81 plus z is 0 plus heat developed by pump is equal to the pressure 66661 divided by 8927.1 plus 5.7830 square divided by 2 into 9.81 plus Z2 is 0.65. Yeah, sorry. So here it is a given Z2 is given as 65. It is not a horizontal. The outlet is above the ground level. So this is Z, and here Z1 will become 0. So in Bernoulli's equation, Z1 and Z2 is not going to cancel. If you consider this is a center line or this is a datum, then here Z1 is equal to 0 and Z2 is equal to 65. So I can solve this equation and I will get HP is equal to 7.2638 meter. As I know HP, then I can find out power output of pump is equal to PO is equal to gamma QH or HP, a head developed by the pump, HP. So this is a gamma. So PO is equal to get power output is equal to 1141.785 watt. This is a specific weight Newton per meter cube into this is a meter cube per second and head is in meter. Meter cube and this meter cube get cancelled, so Newton meter is nothing but joules and joules per second, so this is a kilowatt. Pump efficiency is power output divided by power input. So power it is given, efficiency is given as 0.75 is equal to power output is 11 141.785, and it is asked to find out power input. You can solve this problem also. Similarly, you can solve this problem. Write the given data. The oil pump shown in figure draws a power. P electric power is given. So this is a 35 kilowatt. 35 kilowatt is given. While pumping an oil density is given 860 kg per meter cube, is given 100 meter cube per second. The inlet diameter of the pipe D1 is given 8 centimeter, 0.08 meter. D2 is given 12 centimeter, 0.12 meter respectively. If the pressure rise of the oil pump is measured to be, P is given 400 into 10 to the power 3 Pascal, ton per meter square. So this is a electric motor. Electric motor efficiency is not pump. The electric motor efficiency is 0.90. So this is a power input. So this is P electric is given, and we'll get output from here. Electric motor is PI, which is a input power to pump. So input power to the pump is PI, and electric input to motor is this. So I can find electrical efficiency is equal to PI by P electric. So this is output of electric motor, which is input to the pump. So this PI is, I don't know. This will give me 0.9 is equal to PI divided by 35. So PI, power input to pump, T1.5 kilowatt. Okay, now we'll find a density of oil is given to you, so we can find a specific weight of oil is equal to 860 into 9.81 is equal to, find out the area. A1 is equal to pi by 4, D1 square is equal to pi. So once I know the area, I can find out a velocity. So by continuity equation, Q is equal to A1 V1 is equal to A2 V2. So which will give me V1 is equal to Q by A1 and V2 is equal to Q by A2. So V1 is equal to Q is 100 into 10 to the power minus 3, 19.896 meter per second. And similarly, I will get V2 is equal to 0.09 meter per second. You assume this is a datum line. So Z1, so this is a entrance 1, inlet, and this is outlet 2. So this is a height in downward direction is a Z1 is nothing but suction head, and the height Z2 is nothing but a delivery head HD. So Z1 Z2 is nothing but the head developed by the pump. So apply the Bernoulli's equation at inlet and outlet. Applying Bernoulli's equation at 1 and 2 inlet and outlet. Energy at inlet is 1 by gamma plus V1 square by 2G plus Z1 is equal to P2 by gamma plus V2 square by 2G plus Z2. Collect the pressure terms and we'll collect the Z1 that side. 1 minus Z2 and all this term this side. So P2 by gamma minus P1 by gamma plus V2 square by 2G minus V1 square by 2G. But Z1 minus Z2 is nothing but a suction head. Z1 minus Z2 is nothing but the suction head plus delivery head is equal to H. The head developed by the pump. The same way you can write is nothing but P2 minus P1 by gamma plus V2 square minus V1 square by 2G. P is equal to pressure difference is given as HP is equal to 31.448 meter. So once we know HP, we can find out power developed by the pump. Power output by pump is equal to PO is equal to gamma QHP. So as you know output, we can input, you can find out the pump efficiency. Pump efficiency is equal to pump efficiency pump efficiency is equal to new pump is equal to PO by PI. Don't write 100 here, we'll multiply at last. So is 84.2% by multiplying 100. It was asked, and that's the end of all problems. If you want this file, the total answer of this file, please comment in the video. It will be send you this file by the email address. Thank you for watching.